Coming to the fifth problem, factorize x cube minus 2x square minus x plus 2, x cube minus 3x square minus 9x minus 5, x cube plus 13x square plus 32x plus 20, 2y cube plus y square minus 2y minus 1. So let us find the solution for the first bit, which is x cube minus 2x square minus x plus 2. This is a cubic polynomial. I assume it has p of x is equal to x cube minus 2x square minus x plus 2. Here the constant term given to us is 2. So let us write down the factors for 2. The factors for 2 are plus or minus 1 and plus or minus 2. So let us check it. P of 1, P of minus 1, P of 2, P of minus 2. P of 1 is equal to 1 cube minus 2 times of 1 square minus 1 plus 2, which is 1 minus 2 minus 1 plus 2, which is equal to 1 plus 2 minus 2 minus 1, which is equal to 3 minus 3, which is 0. So we got P of 1 is equal to 0. Since P of 1 is equal to 0, by factor theorem we can say that x minus 1 is a factor of P of x. Now let us write down the given polynomial x cube minus 2x square minus x plus 2 in such a way that we take x minus 1 as a common from that. So rewriting the given polynomial, we get x cube minus x square minus x square plus x minus 2x plus 2. I have written this in this form so that we can take x minus 1 as a common from the given polynomial. Now taking x as common, we get x minus 1 as a common from the first term, and from this we can take x as a common. This is x times x minus 1, and from this we can take minus 2 as a common. So we will be getting x minus 1 as a common. So if we observe, we can find x minus 1 as a common from the first three terms. So we can write it as x minus 1 times of x square minus x minus 2. So the given cubic polynomial is written of the form x minus 1 multiplied by x square minus x minus 2. This is a quadratic polynomial. So we have already known how to find the factors for a quadratic polynomial. So let us write down the factors for this polynomial x square minus x minus 2. So the given quadratic polynomial can be splitted as x square minus x minus 2. This can be written of the form x square minus 2x plus x minus 2, which is equal to, we can take x as a common from first and second term, that is x times of x minus 2, and here we can take 1 as a common, 1 times x minus 2. So taking x minus 2 as a common, we get x minus 2 times of x plus 1. So the given quadratic polynomial x square minus x minus 2 can be factorized of the form x minus 2 times of x plus 1. So the given polynomial x cube minus 2x square minus x plus 2 can be written as x minus 1 times x square minus x minus 2, and this is equal to x minus 1 times. We have already found x square minus x minus 2 as x minus 2 times of x plus 1. So rewriting this, we get x minus 2 times of x plus 1. So the final factorization is x minus 1 times x minus 2 times of x plus 1. These are the required factors of the given cubic polynomial. Coming to the second bit, which is x cube minus 3x square minus 9x minus 5. So the given polynomial can be written as p of x is equal to x cube minus 3x square minus 9x minus 5. So the constant term here is minus 5. So let us write down the factors for minus 5. The factors are plus or minus 1 and plus or minus 5. So let us first find p of 1. This is equal to 1 cube minus 3 times of 1 square minus 9 times of 1 minus 5, which is 1 minus 3 minus 9 minus 5. This is equal to 1 minus 8 minus 9, which is 1 minus 17, which is minus 16. This is not equal to 0, so we can say that x minus 1 is not a factor. So let us check p of minus 1. So p of minus 1 is equal to minus 1 whole cube minus 3 times of minus 1 whole square minus 9 times of minus 1 minus 5. This is equal to minus 1 minus 3 plus 9 and minus 5, which is minus 9 plus 9. This is equal to 0. Therefore, p of minus 1 is equal to 0. By factor theorem, we can say that x plus 1 is the factor of p of x. So the given polynomial can be written as x cube minus 3x square minus 9x minus 5. So we need to write the given polynomial in such a way that we must take x plus 1 as a factor from that. So rewriting the polynomial in this way, we get x cube plus x square minus 4x square minus 4x minus 5x and minus 5. This is equal to, so from the first and second terms we can take x square as a common term and we'll be getting x square times of x plus 1. And from third and fourth term we can take minus 4x as a common. We'll be getting minus 4x times of x plus 1. From the fifth and sixth terms we can take minus 5 as a common. We'll be getting minus 5 times of x plus 1. If we observe, we can find x plus 1 as a common from all the terms. So we can take x plus 1 as a common from the whole, and we can write it as x plus 1 times of x square minus 4x minus 5. So this is a quadratic polynomial. So we need to find the factors for x square minus 4x minus 5. So this is equal to x square minus 5x plus x minus 5. This is because we need two integers such that the sum must be equal to minus 4 and the product must be equal to minus 5. So minus 5x plus x is minus 4x and the product is also minus 5 times of 1 is minus 5. So now we can take x as a common from this, which is equal to x times of x minus 5, and we can take 1 as a common, which is equal to 1 times of x minus 5. Again we can take x minus 5 as a common, we'll be getting x minus 5 times of x plus 1. So the quadratic polynomial can be factorized into x minus 5 times of x plus 1. So the given polynomial can be written as x cube minus 3x square minus 9x minus 5 is equal to x plus 1 times of x square minus 4x minus 5. We have found the factors for the quadratic polynomial as x square minus 4x minus 5 is equal to x plus 1 times x minus 5. So the given polynomial p of x can be factorized as x plus 1 times of, in place of x square minus 4x minus 5 we can write x plus 1 times x minus 5. So the given cubic polynomial can be factorized as x plus 1 times x plus 1 times x minus 5, which is x plus 1 whole square times of x minus 5. Coming to the third bit, which is x cube plus 13x square plus 32x plus 20. So the given polynomial can be written as p of x is equal to x cube plus 13x square plus 32x plus 20. So the constant term here is 20. So let us first write down the factors for 20. Factors are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. First, let us check it. P of 1. So P of 1 is equal to 1 whole cube plus 13 times of 1 square plus 32 times of 1 plus 20. So this is equal to 1 plus 13 plus 32 plus 20, which is nothing but 14 plus 32 plus 20, which is 14 plus 32 plus 20 is equal to 66. This is not equal to 0. So we can say that x minus 1 is not a factor. So next let us check p of minus 1. So now p of minus 1 is equal to minus 1 whole cube plus 13 times of minus 1 whole square plus 32 times of minus 1 plus 20. So minus 1 whole cube is minus 1 and this is 13 times of 1 square is 1 plus 13 minus 32 plus 20. This is equal to minus 33 and this is 13 plus 20 is also 33. This is equal to 0. So by factor theorem, p of 1 is equal to 0. Therefore, x plus 1 is a factor. So now the given polynomial x cube plus 13x square plus 32x plus 20 must be written in such a way that we need to take x plus 1 as a common from that. So the given polynomial should be written as x cube plus x square plus 12x square plus 12x plus 20x plus 20. So this is equal to x square times of x plus 1 plus 12x times of x plus 1 plus 20 times of x plus 1. So if we observe, we can take x plus 1 as a common from these terms. So this is equal to x plus 1 times of x square plus 12x plus 20. So this is a quadratic polynomial. So we need to find the factors for the quadratic polynomial x square plus 12x plus 20. So in order to find the factors for this, we need two integers such that their sum must be equal to 12 and the product must be equal to 20. So x square plus 12x plus 20 can be written as x square plus 2x plus 10x plus 20. 2x plus 10x is 12x and 2 times of 10 is 20. So this is equal to x times of x plus 2 plus 10 times of x plus 2. Again we can take x plus 2 as a common. X plus 2 times of x plus 10. So the quadratic polynomial x square plus 12x plus 20 is factorized as x plus 2 times of x plus 10. The given cubic polynomial x cube plus 13x square plus 32x plus 20 can be expressed as x plus 1 times x square plus 12x plus 20. And by factorizing the given quadratic polynomial, we can say x plus 2 and x plus 10 are the factors. So the given cubic polynomial p of x can be written as x plus 1 times of, in place of this quadratic polynomial, we can write x plus 2 times of x plus 10. Therefore, the factors for the given polynomial are x plus 1, x plus 2 and x plus 10. Coming to the fourth bit, which is 2y cube plus y square minus 2y minus 1. So the given polynomial can be written as p of y is equal to 2y cube plus y square minus 2y minus 1. So the constant term is 1. So we need to find the factors for 1. Factors are plus or minus 1. So let us check p of 1 first. P of 1 is equal to 2 times of 1 cube plus 1 square minus 2 times of 1 minus 1. This is equal to 2 plus 1 minus 2 minus 1, which is 3 minus 3. This is equal to 0. Therefore, p of 1 is equal to 0. By factor theorem, we can say that x minus 1 is a factor of p of x. Now, rewriting the given polynomial in such a way that we need to take y minus 1 as a common from that, we get 2y cube minus 2y square plus 3y square minus 3y plus y minus 1. So from the first and second terms, we can take 2y square as a common. We get 2y square times of y minus 1 plus 3y as common from third and fourth terms. We get 3y times of y minus 1 and 1 as a common from fifth and sixth terms, 1 times of y minus 1. So y minus 1 can be taken as common. We get y minus 1 times of 2y square plus 3y plus 1. This is a quadratic polynomial. So we need to find the factors for this quadratic polynomial. So 2y square plus 3y plus 1 can be written as 2y square plus 2y plus y plus 1, which is 2y multiplied by y plus 1 plus 1 multiplied by y plus 1. So this is equal to 2y plus 1 times of y plus 1. So the quadratic polynomial is factorized in the way which is 2 plus 1 times of y plus 1. the cubic polynomial 2y cube plus y square minus 2y minus 1. This can be written as y minus 1 times of 2y square plus 3y plus 1. We have found the factors for 2y square plus 3y plus 1 as 2y plus 1 times of y plus 1. So rewriting this, we get y minus 1 times of y plus 1 multiplied by 2y plus 1. Therefore, the factors for the given cubic polynomial are y minus 1, y plus 1 and 2y plus 1.